machines. Once again, we're at PowerHouse Engines in Warragul, Victoria, Australia. And here on the dyno, we've got the mighty Ford Cleveland. This 351 Cleveland has been stroked to 408 cubic inches. It's brought CHI cylinder heads and intake manifold and a 950 CFM carb on top. It runs a hydraulic camshaft at around 240 at 50 thou. It's got 10.8 to 1 compression, and this thing is developed to make plenty of torque. It's going into an F truck, so the owner didn't want something too crazy when it came to horsepower, but what he did want was a lot of torque to cart around that weight. So let's give you a rundown on the build specs, and then we'll start ramping this thing up on the dyno and see what we can make. As with every PowerHouse build, this 408 cubic inch Cleveland received high quality machine work and comprehensive blueprinting, all performed in-house to the highest standards, including perfect crankshaft main tunnel alignment, finished with an accurate line honing process to exact tolerances. This is a critical procedure, as not only does it provide effortless crankshaft rotation, a reduction in friction and even main bearing surface coverage, but it becomes the central reference point from which all other key engine block measurements are taken. Another crucial part of the machining process, particularly with the Ford Cleveland's inherently thin engine block deck and cylinder wall thickness, is to torque plate hone the cylinder walls for a perfect piston ring seal. With the torque plate clamped in place, it replicates fitment of the cylinder head and the distortion that the head bolt tension creates within the bore. The exact specification of head gasket must also be positioned in place during the procedure, as it can have an added effect on the level of distortion. The freshly bored cylinder walls are then honed to a finish within 2 microns of tolerance, and a profilometer is utilised to test for optimum RA, RVK and RPK specifications. In simple terms, the profilometer is effectively measuring the microscopic peaks and valleys in the finished surface that are not visible to the human eye. The engine block is also specifically machined to accept a modern one-piece rear-main seal. Moving on, the rotating assembly consists of a SCAT crankshaft, SCAT I-beam conrods with ARP bolts, SRP forged pistons, a total seal ring pack, and a PowerBond Race Series harmonic balancer, all precision balanced to within 0.02 grams. The rotating assembly is then fastened securely by ARP main studs. Compression ratio is a pump-friendly 10.8 to 1, and camshaft is a custom ground comp cams hydraulic roller featuring 240 degrees duration at 50 thou on the intake with just over 620 thou lift at the valve, teamed up with comp cams R-Series roller lifters, all driven by a Rollmaster Pro Series dual row timing set. Crow stainless roller rockers are utilised for reliable valve actuation in unison with heavy-duty chrome moly push rods. Oiling system mods have been performed and are supported by a high-volume ASR oil pan. Cylinder heads are aluminium CHI 3V 225cc variants featuring bronze valve guides, heavy-duty stainless valves, along with matching dual valve springs and retainers. High-performance MLS head gaskets seal the cylinder heads to the block, all securely clamped together using ARP and topped with Ford Performance rocker covers. Intake manifold is also CHI, topped with our 950 HP Holley dyno test carburetor. Ignition is electronic, using a custom advance curve, firing through custom MSD ignition leads to NGK spark plugs, and spent exhaust gases exit via 1 3/4 4:1 pipes. With the engine braking procedure and systems checks having been completed, it's now time to start wide open throttle dyno testing. But before we do, I'd like to ask those of you that haven't subscribed yet to please do so, as it'll help the algorithm and growth of the channel, allowing us to dedicate the considerable amount of time and effort needed to keep some awesome content coming your way, with a whole bunch of car and engine features we have lined up. Either way, we truly appreciate every single viewer's support just by tuning in and watching these episodes. It means a lot. So with that said, let's get back into it and ramp this Cleveland up. We'll set total ignition timing to a conservative 24 degrees. To start with, we'll run it up to 5,000 RPM and see where it's at before taking it to the next level. Well, we're off to a great start with 512 foot-pound of torque and 448 horsepower and climbing at the 5,000 RPM cutoff. This engine won't see high RPM as it's biased towards torque, but it'd be great if it could crack 500 horsepower combined with this big fat torque curve. Now let's turn it to 5,500 RPM and see where it takes us. We're moving in the right direction with 482 horsepower. Now let's take it to 6,000. That's more like it, 494 horsepower and 511 foot-pound of torque. Let's put another 2 degrees of ignition timing into it for a total of 26 and see how it reacts. Well, there were no gains that time, so let's stick another 3 degrees of ignition timing into it with a total of 29 and see how it likes it. We picked up just 2 horsepower with 496 horsepower and 508 foot-pound of torque. That 3 degrees of timing didn't make leaps and bounds, so I'm going to pull it back to 27 degrees and see if we can find a sweet spot somewhere in the middle. Even though there was no sign of detonation heard through my knockbox headphones, sometimes a little less timing in these instances can unlock some power. And while the fueling looks great on the lambda meter for both banks, I'm going to pull a plug to get a snapshot of what's happening in the chamber on one of the leaner cylinders just to be sure. Yes! 501 horsepower! Well, there you go. Mission accomplished. 501 horsepower and 512 foot-pound of torque with a nice fat torque curve that's making 450 foot-pound at 3,000 RPM and also at peak power at 5.9 with a bunch more in between. Perfect for a heavy F truck. But there's one more test I want to try, and that's to fit a 2-inch Aeroflow tapered spacer under this carb to see what happens. The extra height in the plenum area and the tapered 4-hole Venturi style design generally does a great job at increasing airspeed and improving fuel distribution, so it often nets some sort of gain. We shall soon find out. That's a good result, 498.7 horsepower. So a fraction down on peak power, but 517 foot-pound of torque, netting a 5 foot-pound gain. Considering the extra torque and no height restrictions in the engine bay, I'd probably leave it on there. What a great result with this engine, exactly what the customer wanted and perfect for the application, providing a usable package with a mountain of torque. Thanks for watching, we'll see you on the next one.